Okay, Assalamualaikum and hello everyone. So today we are going to cover the rest of 3.2 for week 9, right? So the learning objectives for this week for 3.2 will be to define the first and second ionization energy, IE1 and IE2, okay? And then we're going to analyze the variations in the first ionization energies, so IE1, okay, across a period and down a group, okay? And then we are going to explain the increase in the successive ionization energies. So successive means one after another. So when we remove electron one by one of our element, what will happen? Okay, how do we know the electronic configuration and the group of our element from the successive ionization energies? And then we are going to deduce, that means to state and give a reason. Okay, how do we know the electronic configuration and the position of our element in the periodic table by using the successive ionization energy data just now. Okay, now we are going to define electronegativity. This is just simple, and then explain the variation of electronegativity of your elements in the periodic table, and finally explain acid-base character of oxides. Okay, so our main focus will be on ionization energy and then ionization energies, and then the rest of the learning objectives. Okay, so ionization energy is basically the energy that is used when you ionize. Okay, that means to remove the outermost electron from your gaseous atom or ion. Okay, ionize maksudnya to remove 1 mole of electron. Okay, so you need to know the definition for first ionization energy and second ionization energy. So the first ionization energy means the minimum energy required to remove 1 mole of electron from the outermost orbital or outermost shell in 1 mole of neutral gaseous atom to form 1 mole of gaseous ion from its ground state. So all of this, it actually means this thermochemical equation down here. So minimum energy required, okay, that means that this 1 mole of neutral gaseous atom must absorb this minimum energy in order to remove 1 mole of electron to form 1 mole of gaseous ion. Okay, so this reaction when removing electron is an endothermic reaction. That means you will absorb energy, not release but absorb energy, okay, in order to remove 1 mole of electron. So the definition for first and second ionization energy, you need to have minimum energy required and then the 1 mole for each of the species. Okay, so that is very important when giving the definition. So second ionization energy pula, it is the minimum energy required to remove 1 mole of electron from 1 mole of singly positive ion, okay, to form 1 mole of positive 2 gaseous ion. So basically this one here, okay, instead of our remove electron from atom macam dalam first ionization energy, this one here you are removing from a cation ion, okay, positive ion with +1 charge. Okay, so basically sebenarnya, let's say awak ada atom and then you remove electron and you will form X plus gaseous ion. Okay, ni X plus, ni atom. Okay, and then later awak remove lagi electron, that means the second ionization energy, you will form your X2 plus. Okay, so ini adalah IE1, you remove the first electron and then you remove another electron. Okay, this is IE2 lah. Okay, So basically, the second ionization energy, okay, your energy absorbed will be even more because you are removing from a singly positive ion. Okay, the size is smaller than an atom. That means that you need even more energy to remove the electron. Okay, one mole of electron too. Okay, it is harder to remove. Okay. Alright, so that is first and second ionization energies. So now we are going to look at how our IE changes across period from element to element. Okay, so this is actually you recalling the concept of atomic size. Okay, so you need to be able to explain using that concept in order to explain ionization energy across a period. So we know that from element to element, okay, across the period to the right, okay, the number of proton will increase. Okay, so when the number of proton increases, that means that your ZEF, okay, will increase. Your effective nuclear charge will increase, and then your attraction of electrons to the nucleus will also increase. Okay, so that means that the atomic size, okay, will decrease. Maksudnya size atom awak akan decrease, makin kecil across the period. That means to remove the electron, okay, to remove the electron in the outermost shell across the period from element to element will use up even more energy. Okay, so your IE1 generally you expect it to increase across the period. Okay, it makes sense, right? Sebab dia makin kecil, so more energy is required lah to remove the one mole of electron from each of that element across the period. Okay, but if we look here, okay, if we look here, we can see that the trend is generally increasing. However, there are irregularities, maksudnya dia tak smooth sail increase, tapi ada naik turun. Okay, naik turun, naik, macam tu lah. So patutnya awak expect dia straight je macam tu, tapi dia ada irregularities here between beryllium and boron and between nitrogen and oxygen. Okay, so for these two, okay, these are considered anomalous cases. Okay, case luar biasa atau special case. Alright, so dia tak ikut trend lah, dia tak ikut trend yang kita expect the ionization energy to just increase across the period. So let's see for beryllium and boron first. Okay, kenapa? Why do we have this irregularity? Okay, so for beryllium and boron, okay, we expect that the ionization of beryllium to be lower than boron. So kalau patutnya kalau dia lower than boron, maksudnya awak akan just naik macam awak punya ionization energy akan naik macam biasa je lah, naik je beryllium, boron. Okay, but however, the truth is awak punya beryllium, okay, dia punya energy is much higher than boron. Okay, so there is an irregularity. So this is beryllium, this is boron. So why is this so? So what actually explains this irregularity, this anomalous case, is shielding effect. Alright, so you expect that the boron in group 13 to have a lower IE1, first ionization energy, than beryllium in group 2, kan? But your beryllium, it loses a 2s electron while the boron loses a 2p electron. So this 2s electron, okay, it is only shielded by the electron in the 1s orbital, while this 2p electron is shielded by the electrons in 1s orbital and 2s orbitals. So there are electrons in two orbitals that are shielding the 2p electron in boron. So this means that, okay, it is easier to remove this electron, okay, compared to removing this electron in beryllium. Okay, less energy is needed to remove an electron from a higher energy of partially filled 2p orbital because it is highly shielded, okay, from the nucleus attraction by the 1s and 2s orbital, as in boron. Okay, banyak elektron yang shield this electron. Maksudnya banyaklah block out punya effective nuclear charge tu rendah lah untuk yang ni. Okay, so lebih mudah untuk remove this electron banding dengan electron in 2s orbital of beryllium. So therefore, since this one is much easier to remove its electron, okay, this electron, that means that the IE1 for boron will be lesser than the IE1 for beryllium. Okay, sebab beryllium is only shielded by 1s electrons in the 1s orbital, satu saja. So it is not that shielded compared to the 2p electron in boron. Okay, so maksudnya lebih mudah lah untuk nak remove electron daripada boron. Okay, that's why dia punya energy is IE1 dia, ionization energy dia lebih rendah. Okay. Okay, so next for nitrogen and oxygen pula, we expect that the ionization energy for nitrogen to be lower than oxygen, but actually the ionization energy of nitrogen is higher than of oxygen. So this case pula, it is explained by the stability of orbital. Okay, so in this case for nitrogen actually has a half-filled 2p orbital. Okay, 2p3 maksudnya macam ni, 2p 1, 2, 3. Okay, half-filled 2p orbital, while your oxygen, it is a partially filled 2p4. So maksudnya dia ada lagi satu elektron dekat sini. Okay, so this is a partially filled 2p orbital for oxygen. So when you are removing that one electron and that one electron, okay, you know that the half-filled 2p orbital is much more stable than the partially filled 2p orbital. So the repulsion between electrons in the partially filled orbital in oxygen here makes it easier to remove the electron than to remove the electron in the 2p half-filled orbital, because the half-filled orbital is much more stable than the partially filled orbital 2p. Okay, so first ionization energy of nitrogen is higher than that of oxygen. That's why there is an irregularity between the ionization energy of nitrogen and oxygen. Okay, so now we are going to look at another variation, which is the ionization energy going down the group. So ini pun sama juga, we will recall the atomic radius punya explanation. Okay, so cakap lah pasal number of protons, shielding effect, attraction between outermost electrons to the nucleus, and then the size of your atoms going down the group. So the size of your atoms going down the group is increasing. Okay. So therefore, since it is increasing going down the group, maksudnya the electrons are much more further away when going down the group, right? So it is held less tightly to the nucleus when going down the group. Therefore, it is much more easier to remove the first electron, okay, from element to element down the group. So that means the ionization energy decreases going down the group. Okay. So obviously lah, lebih mudah untuk nak remove the first electron, the 1 mole of electron from this element here. Okay, yang besar ni with a larger size than this one. Then this one. Then this one. Okay. Right. So, okay. So, now we are going to explain why going from ionization energy 1 to ionization energy 2, okay, IE3, IE4, okay, the trend of ionization energy is increasing. Okay, kenapa nak remove electron? Okay, makin lama makin tinggi energi dia. It is actually basically because, okay, daripada for ionization energy 1 you are removing daripada atom. Okay, so bila remove daripada atom and then you will form cation, kan? So that one kita ada +1 charge lah. Okay, so this is IE1. So IE1, that is the amount of energy that you will use. From IE1 to IE2, you will remove 1 more electron. So your cation will become smaller. Okay, you remove more electron. That's why awak punya charge tu makin lama makin kecil. Makin positive. Okay, remove 1 electron. Okay, so when you remove electron daripada a singly positive ion, okay, it is becoming much more harder compared to when removing from an atom, because the size of your +1 ion ni makin kecil banding dengan atom. Betul? Okay, so makin susah lah nak remove electron. Alright, so sama juga for IE3 lebih tinggi dia punya energy. You need even more energy to remove electron from a +2 cation, +2 charge cation, okay, to form a much more smaller cation. Okay, so that's why our ionization energies always increase in this following order, from IE1 to IE2 to IE3, IE4. So IE9, let's say, removing the 9th electron will require even much more energy, because our akan remove daripada a very small cation. Okay, makin lama makin susah lah awak nak remove electron. Okay, so daripada IE1 to IE2, IE3, IE4, this is called successive ionization energies. Okay, successive maksudnya one after another. So remove the first electron daripada atom. Okay, that is IE1, the energy required to remove the first electron. IE2 is the energy required to remove the second electron. Okay, daripada elemen yang sama. And then IE3 is to remove the energy required to remove the third electron. Third electron. IE4 for fourth electron, and so on. Okay, so that is successive ionization energy, and we can use the data given, okay, successive ionization energy of an element to find the electronic configuration of the valence electron of an element, and you can also find the group of your element because you already know the electronic configuration lah. The valence electronic configuration. Okay. So for this example here, okay, we have a beryllium element, beryllium atom to be exact. So in this case, you know that you have 4 protons. That means for the atom, you have 4 electrons. Okay. So we are going to remove 1 electron one by one. Okay. Given the data IE1, this is the energy required to remove the first electron. IE2, energy required to remove the second electron. Okay. IE3, the third electron. IE4, the fourth electron. So in this case, awak tengah remove all the electrons from beryllium lah. Okay. Sebab dia bagi 4 successive ionization energies when you have 4 electrons. Okay. So generally, you will not be able to find the period of your element, okay, if you do not know the total electrons given. But in this case, for beryllium, you know the electrons, you have 4, so you can find the period. But in other cases, like let's say kalau dia bagi elemen X je, dia tak bagi pun the total number of electrons, okay, then you cannot know the period. You can know the group though. Okay. So, how do we find the valence electronic configuration of our beryllium element given the successive ionization energies here? The first thing that you have to do is to find the IE ratio or IE difference to find sharp increase. The sharp increase will tell you which electron is removed from the inner shell. Okay, so IE ratio means, okay, since we have IE1, IE2, IE3, IE4, you will do division of IE2 over IE1. So this means this is the ratio, the IE ratio going from IE1 to IE2. Okay, so this is the ratio going from IE2 to IE3. Okay, and this is IE4 to IE3. IE3 to IE4. Okay. So on your right here we have IE difference. Difference means you are going to just subtract the ionization energy with the other. So IE2 minus IE1, IE3 minus IE2, IE4 minus IE3. Okay. So now that we have the values, okay, these values, we will find the sharp increase. Okay. So you find that the sharp increase, okay, if you do IE ratio, it is going from IE2 to IE3. Okay. Sama juga kalau buat IE difference, you will find that the sharp increase is going from IE2 to IE3. Okay. So maksudnya there is a sharp increase between IE2 and IE3. What does that mean? That means that, okay, bila awak remove electron awak, okay, awak punya IE, okay, this is number of electrons removed. Okay, first IE remove 899. Let's say here 899, and then 1757, and then you have a sharp increase from going from IE IE2 to IE3. So maksudnya ada sharp increase macam ni. Okay, tinggi. And then IE4 pula, dia back to normal. So what does this mean? Okay, going from here to here to here, you have a sharp increase right here. Okay, so this one is the ionization energy when you are removing the first electron. This one is removing the second electron. This one is removing the third electron. And this one here is removing fourth electron, ionization energy. Okay, so we found that when removing the third electron right here, we have a sharp increase. So that means your third electron, is located in the inner shell. You are removing electron from the inner shell. Okay, when removing the electron from the inner shell, you will require even more energy banding dengan removing electron in the outermost shell. Okay, so since we are removing electron, let's say 1s2 and 2s2 kan, kita punya electronic configuration untuk beryllium. Okay, so you have this shell. Okay, so you are removing the first two electrons. Okay, yang dua ni, you do not have sharp increase, IE1 dengan IE2. That means these two electrons are in the same energy subshell that is in the outermost shell. Okay, so bila awak dapat tahu that the third electron is removed from a different shell, that means that it is actually removed from an inner shell. Sebab awak memang buang elektron daripada 2s dulu. Okay, 2 elektron ni. Lepas tu awak akan masuk ke dalam kan. Awak buang dari luar kan. So first awak buang 1, 2. Okay, masa tu awak punya IE tak ada sharp increase. Sebab they are located in the same shell. But going to the third electron, when removing one electron here from the 1s orbital, you have sharp increase. Okay, removing the third electron. So this tells you that the third electron is located in the inner shell. Okay, so from there, since you know that the third electron, okay, yang ni, IE3 ni, ada sharp increase. Okay, that means the third electron is located in the inner shell. You know that the first two electrons are your valence electrons. So beryllium has 2 valence electrons. So daripada sini, we can know the valence electronic configuration for beryllium, which is Ns2. Okay, you have to tell the valence electronic configuration of your element. Okay, in other cases, kita takkan tahu the period unless you know the total number of electrons. So you will only give it in this format Ns2. Okay, so you can conclude that beryllium is in group 2. Alright, so let's say kalau awak punya sharp increase is at IE4, ada sharp increase kan. That means that your fourth electron is removed from the inner shell. So that means the first, second and third electrons, okay, are located in the same subshell, which is your valence shell. Okay, so when you remove 3 electrons, that means that your element is located in the group 13. Okay, group 13 P block. Okay, so it is not D block. Okay, because your D block elements you will remove daripada 4s orbital dulu baru 3D. Okay, So bila ionization energy ni, kita akan main dengan S block dengan P block saja, okay? Alright. Okay, so that is your first example. The second example, I would like you to do it yourself. And the exercises as